So following on from the previous video, we got to this stage here. Hang on, we got to this stage here, and then I asked you to write this down on a scrap piece of paper here, because later on I'm going to ask you to recall this. So basically, what this is saying is that sine of alpha plus beta will equal this, and this thing here will equal this. Now, so continuing on from here. So at the end of the previous video, we got to this stage here. Now, our next step is that from above, and what I mean by from above is that right from the start. Hang on. Right from the start, this was our aim here. This was our aim. Our aim. We've already proved these two identities here. We're going to use this one here to prove this and to prove this. So now I'm going to just remember this here. It's like me cutting and pasting this. I'm now extracting this bit here. Okay. So when I say from above, I actually mean this bit here. So this, we've already proved this here. So I'm going to start from this point here. Okay. So remember this this identity here. So I'm moving it down here. So when I say from above, when I say from above, that's from above. So that's this bit here. Okay. So at the end of the previous video, we got to this stage here, and from above means from above. So from here, whenever you have whenever you have a bubble plus another bubble, you can immediately jump to this. Okay. So now I'm going to put this into here, and then I'm going to put this into here, and then I'm going to put this into here. Okay, and this second bubble here, which is this one here, we're going to put it into here, and then we're going to put it into here, and then later on, so basically we've already proved this here. I'm just going to use this. I'm just going to put this into here, and this into here, into here, and then this into here, and then I'm going to do some blah 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 stuff over here. I'm going to do some blah 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 stuff, and then I will get to a point. I will get to something, and then later on, because this is equal to this, later on I'm going to say, oh, by the way, because this is the same as this, and this here is the same as this, then I'm going to say, oh, sine alpha plus beta will equal this thing here. Okay, so you see what I mean later on. So we've already proved this here. I'm going to put this into here, and then well, I'm just going to use this this identity here. Whenever you have one bubble plus another bubble, we can immediately jump to this. Now I'm going to use this and do some blah 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 and get to a final stage. Later on, I'm going to say, oh, by the way, this final stage here is sine alpha plus beta. Okay, I'm gonna move this here, and then say that sine alpha plus beta equals blah 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 over here. Okay, so at the end of the previous video, we got to this stage here. We've already proved this here. So now we're gonna move this into here. We're gonna put it into here, and we're gonna put it into here. So that will take us to this stage here. Okay. So whenever you have a bubble here, whenever you have cos a bubble plus another bubble here, you can immediately use this. So we're putting this bubble here into here. And then into here and so on. That would then give us this. That would then give us this here. Okay. Now look at this here. Let's just look at this bit here. Let's just look at this block only. Okay. Now recall from the previous video that this here is your sine. This is your sine of x. Okay. This is your cos of x. Now whenever you have, now looking at this here, okay, we are just looking at this bit here. Whenever you have cos of x, look at this. So you start with your cos of x, and then if you apply this transformation here, if you apply this transformation, x minus pi over 2, it means you shift it to the right. So that will, if you start at this and then apply this transformation, you would get this cos of x minus pi over 2. And when you apply this transformation, you shift everything across. So you will end up so it will equal sine of x, really. It will equal sine of x. So this thing here, um hang on. So this thing here is sine of x. Okay, this thing here is sine of x, because if you start at cos of x and then you apply that transformation, x minus pi over 2, it will lay the blue line on top of the red line, meaning it will equal sine of x. So my point is that this thing here, equals sine of x. So this then becomes this. It's much neater. You see, here you've got cos of a complicated bubble here, and now it's just simply sine alpha. Okay, so this whole thing here is sine of x. Okay, now look at the other complicated thing, which is this bit here. Now looking at this thing here, remember, so this thing here, you're starting with looking at this block here. Okay, so the red line is your sine of x, the blue line is cos of x. Now if you start at sine of x, okay, so you start out with your sine of x, apply this transformation here, sine of x minus pi over 2. That means you shift it to the right by pi over 2. So this red line here will get moved to over here, and basically if you apply that transformation, it will then become this. Hang on, it will then become this. It will then become something like this. Hang on. It will then become something like this. My point is that starting at sine of x, if you apply this transformation here, minus pi over 2 here, it will then move across here. This point here will move across to here. So and then this point here will move across to here. So basically you will have this line here. Okay, so applying that transformation will give you something like this. So starting at your sine of x, which is the red line here, if you apply this transformation here, you will get this purple line here. But this purple line here is the negative version of the cosine. So hang on. So starting at your sine of x here, if you apply this transformation here, you will get to this. You will have sine of x minus pi over 2. Okay, but the thing is, sine of x minus pi over 2 is this purple line here. But this purple line here is a negative version of the cosine of x. So you can say that this thing here is equal to negative cos of x. Because if you look at the purple line here, is the negative version of the blue line. Because if you look at the purple line, and then so the blue line is cos of x. If you stick a negative cos of x in there, it will be the same as the purple line. So the purple line is the negative version of cos of x. So my point is that if you start at sine of x, well, overall this bit here will be minus cos of x. Okay, so this whole block here is minus cos of x. So you can think of this block here as a minus 1 times cos of x. Okay, so this block here is minus cos of x. Now think of this block here as a minus 1 times a cos of x. So minus 1 and a minus 1, that will give you a positive. Okay, so basically from here, okay, remember that this thing here is simply sine alpha. This thing here is minus cos of x. So now tidy this up. This thing goes out here, making this a positive. So basically you would get to this. Okay, you would get to this. Look at this here. This here is much neater and simpler. Up here is really complicated because you've got cos of x and then sine of this complicated bubble here. By taking it, so this bit here is sine alpha. This bit here is minus cos alpha. And then tidy it up, it will take you to this stage here. So look at this, nice and tidy here. Okay, so this complicated thing here is this thing here. Okay, but remember, I asked you to write this down on a scrap piece of paper. Earlier, this whole thing here was simply this thing here. So we can actually remove this and put this into here. So that we can say that this thing equals this thing here, and it was what we were trying to prove. Okay, so basically this complicated thing here is this thing here, but because earlier I asked you to write this down on the scrap piece of paper, this thing here is the same as this. So let's just say this thing here, which is this bit here, equals this thing here, which is this thing here, and this is what we set out to prove. Okay, so that's one of the identities that we wanted to prove. So we've done the bottom two, and this one was the second one. Now, so basically, once you've got to this stage here, you can imagine this as being what this is saying is that whenever you sine an angle, whenever you sine a bubble, and then plus another bubble here, you can immediately jump to this. That's what it's saying. Whenever you sine an angle and then you have another angle, you can immediately jump to this. So that's like you saying, when you have one angle here plus another angle here, so well let's just put minus beta into here. Okay, because minus beta is an angle. You can think of it as like this. You can think of so this here is let's just say beta here. So minus beta is another angle basically. So you can put minus beta into here. So minus beta, minus beta, minus beta here. Okay, so now tidy this up. So when you put minus beta into here, basically it will become this: sine alpha minus beta, because you take the minus out and put it out here. So it will then, so this thing here will then become this. And remember, cos minus beta, that's an even function. Remember, cos looks like this. Cos of x looks like that. So yeah, so this thing here becomes this thing here, and remember that sine of minus an angle, that equals well, it equals negative, and then it will be sine beta. So when you have minus beta here, this block here is minus sine of beta. Okay, so now here is a positive, and then you've got a minus here, so that will then become this. So overall, it will become this. So once you've got to this stage here, you can simply just put minus beta into your second bubble, and then the whole thing here translates to this. So therefore, we've proved all four identities here. We've done these two, and then we use this here to prove this, and then from this here we would put minus beta into here to prove this. Okay, so now we've proved all four. Okay.